Alright guys, remember before when we used to take binomials like m plus 5 or g minus 7 or 2x plus 9 and we would square them or multiply them by themselves. And we would end up with a product that was called a perfect square trinomial. Well, in this lesson, we're going to learn how to take those perfect square trinomials and factor them. That is, find out which binomial was multiplied by itself in order to get it. Now, just to kind of freshen our memories, and because this information is going to be really helpful for us, let's take a moment to review what happens when we square a binomial, when we multiply it by itself. So for instance, if we multiply m plus 5 by m plus 5, I think we get an m squared, I think we get a 5m, we get another 5m, that's going to be key, and 25, for a grand total of m squared plus 10m plus 25. And as we make our way through, I want you to think about, if you were to look at this trinomial, how could you determine that m plus 5 was the thing that was squared to get it? Obviously, we've got an m squared, we've got a 25, which is 5 squared, but then also we want to consider this 10m. So food for thought. With g minus 7 times g minus 7, I think we're going to end up with g squared minus 7g, another minus 7g, and negative 7 times negative 7 is still plus 49, for a grand total of g squared minus 14g plus 49. So again, I want you to think about, if you were looking at this trinomial, how would you know it was a g and a 7? Well, I see a g squared and a 7 squared. And how would you know it would be minus 7? And how does this minus 14 work into our thought process? Making moves, 2x plus 9 times 2x plus 9. I think 2x times itself is 4x squared. 9 times 2x is 18x. We're going to get another 18x, and 9 times itself is 81, for a grand total of 4x squared plus 36x plus 81. Again, I want you to do that same process. If you were given this trinomial, how could you tell it was 2x and 9 that needed to go in our binomial that's squared in order to get this? And in the last one, same idea. B squared times b squared is b to the 4th. B squared times negative 3 is negative 3b squared. We get another one of those, and negative 3 times negative 3 is 9, for a grand total of b to the 4th minus 6b squared plus 9. And in general, if we're ever squaring or multiplying by itself a binomial of the form a plus b, whatever a and b are, we are always going to get a product of the form a squared plus 2 times those two terms multiplied by one another, plus, of course, b squared. And I urge you to confirm that this is the form of, for instance, this binomial squared and this binomial squared. Of course, if it was a minus b quantity squared, it would just be a squared minus 2ab plus b squared. All right, and so our challenge now is, if we are given a perfect square trinomial of this form, how do we figure out the binomial that's squared to give it? And here's the general strategy I do. First, of course, we're going to put our trinomial in standard form, always. Second, we're going to look for common factors, always. Then third, we say, well, listen, if our first term is a perfect square and our last term is a perfect square, it is the square of something, then we may just well have a perfect square trinomial. And then it's going to be up to looking at that middle term and making sure that it kind of fits the bill. We want to make sure that it's twice the product of the first and last term. So let's do some examples right now just to try. All right, so in our first one, negative 8h plus 16 plus h squared, first things first, let's go ahead and put this into standard form. So h squared minus 8h plus 16, and no common factors. So let's go ahead and look at the first and last terms. That first term, h squared, yep, that's a perfect square. It is, well, h squared. Is 16 a perfect square? Absolutely. That is 4 squared. So this thing, they very well may be a perfect square trinomial. If it is one, it'll either be h plus 4 or h minus 4 quantity squared. Now, how do we figure out which one it's going to be? Well, let's look at this middle term, negative 8h. That negative sign tells us that it's going to have to be h minus 4 squared. And to confirm that this is actually the factorization, we've got two options. We could go ahead and multiply it out. So why don't we do that? H minus 4 quantity squared is, let's see, h times h is h squared. H times -4, we get a -4h. We get another one, plus 16. H squared minus 8h plus 16. Booyah! Absolutely. Works out great. The other thing we do is say, listen, remember from our general form of a perfect square trinomial, h times -4 is -4h. And do we have 2 of these -4h's as our middle term here? Absolutely. So that's a quick way to check and make sure that this is the correct factorization. So awesome. All right, moving on. Let's go ahead and put this in a standard form right away. G squared plus 14g plus 49. Awesome. Any common factors? No common factors. Let's take a look at this first term, g squared. That is definitely a perfect square. It is the square of g. 49, is that a perfect square? Absolutely. That is the square of 7. Okay, so we're thinking this guy very well may be a perfect square trinomial. So it's going to be either g plus 7 squared or g minus 7 squared. Now, I'm looking at this middle term, plus 14g. It looks like it's probably going to be a trinomial of this form, so it should be g plus 7 quantity squared. Again, we can actually multiply this out to confirm, but let's see. When we do so, we're going to get a g squared. We're definitely going to get a 49 as our last term, and we're going to get 2 times 7 times g. We're going to have a g times 7 and a 7 times g, and when we get 2 of those, we'll get 14g. So this is indeed the factorization, and we confirm that it's right. All right, another example. M squared plus 10m plus 16, already in standard form. Awesome. Okay, let's take a look at this m squared. Is that a perfect square? Absolutely. That is the square of m. Let's take a look at this 16. Is that a perfect square? Absolutely. That is the square of 4. So we're thinking that this guy very well may be a perfect square. And if it is, it'll either be m plus 4 quantity squared or m minus 4 quantity squared. And well, let's see. That plus 10m as our middle term tells us, okay, if it's going to be anything, it's going to be m plus 4 quantity squared. Let's actually multiply this one out to see if it actually matches our original polynomial to make sure we factored it correctly. So if we were to multiply that out, m plus 4 times m plus 4, well, I think we get m times m, which is m squared. We get a 4m. We get another 4m. Uh-oh. Oh, no. So indeed, it appears that this polynomial right here does not match the product of m plus 4 times itself. So this is not the factorization of m squared plus 10m plus 16. So let's make that very clear. Not equal to. This is not a perfect square trinomial. Even though this first term is a perfect square, even though this last term is a perfect square, this whole polynomial is not a perfect square trinomial. So that's going to happen sometimes, and we just got to be really, really diligent about not assuming it's a perfect square trinomial, even though our first and last terms were perfect squares. In fact, this polynomial factors as m plus 2 times the quantity of m plus 8. And I leave it to you to multiply this out and confirm that this is the correct factorization. This is a skill we're going to learn how to do really soon, but not quite yet. All right, let's check out a few more examples. And I left this general form in the upper left-hand corner here so we can continue to reference it as we go. All right, so how about 2b squared minus 12b plus 18? It's already in standard form, which is great, but I'm noticing this first term, 2b squared, that doesn't look like a perfect square. 2 isn't really what we think of when we think about a perfect square, and neither is 18. I mean, unless you want to talk about weird square roots and irrational numbers. So at first we might worry that this isn't a perfect square trinomial and we might not be able to factor it. But when I look at these terms, if I look for a common factor, we see, oh wait, 18, -12, and 2 all have a common factor of 2. So let's go ahead and factor out a 2 from each term in this polynomial. And we're left with 2 times the quantity of b squared minus 6b plus 9. And now, let's take a look at this remaining trinomial right here and see if this could be a perfect square. Well, I'm looking at b squared to begin with. B squared, that's definitely a perfect square. That is b squared, not surprising there. Well, 9, that's a perfect square. All right, that's 3 squared. So I'm thinking that this trinomial right here could be a perfect square. it could be b plus 3 squared or b minus 3 squared, and that negative 6b in the middle of that polynomial, this term right here, that negative 6 tells us it might be b minus 3 quantity squared. And with a little mental check, if we were to multiply this out, we would get a b squared, we would get a negative 3 squared, and we get 2 times a times b, so 2 times b times negative 3, that's negative 6b, boom. This is the factorization of that trinomial. Don't forget our common factor from before, that 2. So the full factorization of that original polynomial is 2 times the quantity of b minus 3 squared. So always want to look for those common factors. All right, let's make our way to some more. Here we go. This one, it's already in standard form. That's great. Any common factors? 9, negative 12 form? Nope. All right. Time to look at our terms and see if it fits this form. So 9m squared, is that a perfect square? Indeed it is. That is what you get when you square 3m. All right. 4, is that a perfect square? Absolutely, that is 2 squared. So if this trinomial is a perfect square trinomial, we're thinking it's going to be 3m plus 2 or 3m minus 2 quantity squared, and this negative 12m tells us that if it's anything, it's going to be 3m minus 2 quantity squared. And when we multiply this out, this is kind of like this form. We would get a 3m quantity squared, that's 9m squared, negative 2 squared, that's going to be 4. And do we get 2 times 3m times 2? Let's see, 2 times 3m is 6m, times 2 is 12m, and we get that indeed right here, minus 12m, so this is the correct factorization. You are also always welcome to actually multiply this out to confirm. Awesome, I'm going to put an equal sign there to show that that is the factorization. Over here, okay, we are already in standard form. There are no common factors that I see. Let's take a look at this first term right here, 16h to the 4th. Is that the square of something? Yes, that's what we get when we take 4h squared and square it. So this first term is a perfect square. 25, absolutely, that is the square of 5. All right. This plus 40h as our middle term leads us to believe that if this guy is a perfect square trinomial, then it will be 4h squared plus 5, all of that squared. I know that's a doozy to say, but we got to be really, really careful about making sure what's being squared and when. I'm going to move this down a little bit so we can see it. Awesome. Okay, let's just confirm. If we square the first term, we get 16h to the 4th. If we square the last term, we get 25. If we were to multiply this out 2 times, we would get 5 times 4h squared. 5 times 4h squared is 20h squared. Twice that is 40h squared. Amazing. Everything checks out. Phenomenal. All right. Booyah. All right, making our way onwards. In this example, once again, we are in nice standard form. How convenient. Are there any common factors? I don't see any common factors. We're ready to rock. Let's do this. All right. 36n to the 2nd power, is that a perfect square? Absolutely. That's what we get when we take 6n and square it. Another 25. All right, I'll take it. That's a perfect square. That's 5 squared. So if this trinomial is a perfect square, then it would be the perfect square of 6n plus 5 or 6n minus 5 squared. This negative 30n tells us it would be 6n minus 5. Okay, let's just quickly confirm. This is a binomial of this form, so if we square it, we're going to end up with a trinomial that looks like this. So we're going to get a 6n squared. That is 36n squared. Awesome. Negative 5 squared is 25. Phenomenal. And we're going to end up with negative 2 times 6n times 5. So 6n times 5 is 30n, times 2 is 60n. Oh no! But we have a negative 30n here. Oh man! So this, however tempting it may seem, is actually not the factorization of this perfect square trinomial. And you could always multiply this out just to confirm. And if you did, you would actually get 36n squared minus 60n plus 25. So this is not the factorization of this trinomial right here. Once again, so tempting because the first term was a perfect square and the last term was a perfect square, but we always got to make sure, just in case. Okay, Last one. This guy is already in standard form. Fantastic. Let's look for some common factors. Ooh, I think I do see a common factor of 5 for all these coefficients. Now, I'm actually not going to factor out a 5. Why not? Because when we factor out that common factor, we'd like our first term, our leading term in the remaining polynomial to have a positive coefficient. So what I'm going to actually factor out now is a negative 5. So what we're going to end up with is we're going to end up with negative 5 times the quantity of 4m squared. And see, that was the point right there. That positive 4 as our leading coefficient was what we really wanted. It's going to make our life a lot easier. Minus 20m plus 25. And now that we've put our polynomial in standard form, and now that we've taken out a common factor, now let's look at our remaining trinomial and see if this could be a perfect square. Oh, check it out. 4m squared. That looks like a perfect square to me. That's what we get when we take 2m and we square it. 25, I mean, geez, a lot of 25s in this video. I'll take it. That is a perfect square. That is 5 squared. Okay, so I'm thinking that if this trinomial right here is a perfect square, then it's going to be 4m plus 5, 2m plus 5 quantity squared, or 2m minus 5 quantity squared. I bet you can tell that, yep, 2m minus 5 quantity squared. I'm going to leave it to you to double check, but I'm going to do it in my head. Let's see, 2m squared, 4m squared, negative 5 times 2 is negative 10m, twice that. Boom! Awesome. That this, when we multiply it out, will indeed give this trinomial. Let's not forget about our common factor, so we're going to toss a negative 5 out in front. And right here, this is the final factorization of this polynomial right here.